Upload these somewhere.
Yeah, that's right there earlier.
Are we right to go?
No.
No?
Oh, yes.
Okay, so we know that our protons and neutrons are in the nucleus, and our electrons orbit the nucleus. That's what this is what the Bohr model brings us to. Orbit's not an ideal word, but we've got the idea that the nucleus has the protons and neutrons, which is correct. And the electrons are actually a long way away from the nucleus. Most of the atom is empty space, which is why when Rutherford was firing his alpha particles at that sheet of gold, most of the time the particles went through undeflected. They could go through and not hit anything. So let's focus a little bit more on the electrons.
I wonder if it's empty.
Sorry?
Just made a joke.
Oh, tell me.
I said, no wonder I feel so empty.
Oh. I don't
Joking
know if
about
that's a joke.
Do you have any food for lunch, bro? Just fills you up.
and a whole pack of coffee.
Feeding.
Cool things.
Okay. So our protons and neutrons are in the nucleus, and that's the main part of our mass of the atom. And then our electrons orbit the nucleus. There is an order to the way they do that. And there's a maximum of 2 electrons in this orbital closest to the nucleus. And it's really all to do about just packing and space. It's a function of volume, geometry. But when we get to the next orbital, we can fit 8 electrons. And often in physics it's called a shell. Shell's a bad word because if you think about like an eggshell, if you imagined that being an orbital, then you'd think that the electrons are only on the surface of the shell. But in actual fact they can be, they whiz around in all other ways. They're not stuck on the surface of the shell. That's one of the reasons why the Bohr model actually breaks apart. But for physics purposes, this is how we answer questions when we're talking about electron configurations. You can see that I also put them in pairs because that's what they do. They 100% get around together in pairs. And if you're going to do chemistry 4, then you'll learn a lot more about why. And the limit of our exploration of electron configurations in physi is the 3 orbitals. So the next one, the third shell, also has a maximum of 8 electrons. So if we look at which element this was, which one do you think would be? If we see how I've got 18 electrons there. Argon. Yeah, and what would happen if which element would this be? Sulfur with 16. Obviously, we're talking elements at the moment, so that means that the number of protons in the nucleus must match the number of electrons that we've got. This outer shell, no matter which one is the outside, so if it's a small element like the hydrogen there in our picture on the bottom of page 18, it's only got one shell, so it's only got an outer shell. If we look at the sodium, it has 3, and the chlorine has 3. All of the chemical reactions occur with the electrons in the outer shell. Okay, so the outer shell is really important from a chemistry perspective. Inner ones don't react. And we have a special name for the electrons in that outer shell, and they are called valence electrons. This helps us to categorize the potential chemical reactions that an element can undergo. Okay. If I were to write out the electron configuration for argon, I have to state how many are in each of its shells. So that would be 2, 8, 8. If I were to write out for sulfur, it would be 2, 8, 6. Does that make sense? So what we're looking at is how many are in each of the orbitals, and we just write them as numbers separated by commas. All of the elements in group 1 on the periodic table, so if you want to get out your formula sheets and have a look, group 1 is the group along the left-hand side, so it starts with lithium. Even though hydrogen has been positioned there, it would be better if there was a gap. Like if you look on the periodic table on the wall over there, even though hydrogen is sitting at the top of group 1, you can see that it's separated. And so the chemistry of hydrogen is different from the other metals that are in group 1. So lithium is the first metal in group 1. Lithium, sodium, potassium, rubidium, cesium, francium in group 1. The thing that they all have in common is that they have one valence electron. And so It doesn't matter how many shells I draw as we go down the group and the element atom gets bigger and bigger with more and more shells of electrons. For all of them, they will only have one electron in their outer shell. And they are metals, which means that when they react, they do so by donating that valence electron to another substance, which leaves them as an ion with what kind of charge?
Positive.
Yeah, it's going to be a positive charge because now they've got more protons in their nucleus than they have electrons. And this is what metals do. If we look at group 2, which starts there with beryllium, and then you've got magnesium, calcium, etc., they have 2 valence electrons. Okay, so they've got 2 electrons in their outer shell. And this is why the periodic table is arranged the way it is, that as we move across from left to right, we are increasing the number of electrons we have in our valence shell, in that outer shell. Now, we don't worry about the transition metals in Psi. So that big block in the middle where they dip down, we just don't worry about that. We are interested in the ones on the outside. So 1 and 2, and then we zip all the way over to 13, 14, 15 as the group numbers at the tops of the columns. You might also notice that there are Roman numerals above the Arabic numerals. And they go 1, 2, and then they go all the way, they skip the transition metals across to 3, 4, 5, 6, 7, 8. Now the Roman numerals correspond with the number of valence electrons present in each of those groups. Okay, so if you're talking about a group, you have to be very careful whether you're using Roman numerals or Arabic numerals. If you get them mixed up, then you're going to be talking about potentially the wrong spot on the periodic table. Okay, so you can't say group 7 with an Arabic numeral when you mean VII, okay, because that's actually group 17. You know what I mean? If you have a look on there, the group 7 is in a whole different spot than, okay? So that's just something to be aware of. Now, there are some questions on page 19 about valence electrons. And there's a little bit about ions. We're just going to skip the ions because it's out of this. Okay. Does anyone have any questions about